Welcome everyone, Mr. Allen here. I'm just going to run through today kind of the note here on counting principles, activity 1 from unit 1 of the data management course. There won't be a lot of content here that's too hard. Essentially, we are learning to count. Now, hopefully you have a pretty good idea how to count when items are already there in front of you. But in this case, we're looking at ways to either organize data so that we can make it more easily counted, or eventually trying to skip organizing the data at all and just kind of go from the data from the information we have to find a shortcut to get the number of items that we're discussing. So our first option here, we just have a simple list, basically given some options, list off the possibilities. And so here we're looking at making names out of possible first names and middle names, and I think intuitively you can kind of figure this one out. My options are Dylan Andrew, Dylan Jeffrey, Matthew Andrew, Matthew Jeffrey, and Christopher Andrew, Christopher Jeffrey. So there are 6 possible names. Check the answer just to be sure, and of course you can sort of see just listing them off is fine. For a small number of items, of course, that's going to work pretty well. With a larger list and a more complex list, of course, that's going to be a little bit tougher. So we should have some other options available to us. And in order to keep things organized, a better option as the problem set grows might be a tree diagram. And you can just sort of see this quickly here. Maybe I can zoom a bit. Essentially, the idea is starting from a 0 point, I suppose. We look at all the different possibilities for our first choice, in this case, the 3 names for the first name. And then following that, we branch off for the possibilities for the second choice. I think that's all this one says here. And then, of course, you can sort of, at the end, realize that there were 1, 2, 3, 4, 6 paths to get to the end here. The final line here tells me how many options there were. There was one path that got me here, one here, and so there are 6 different possibilities this way as well. So again, nothing different from that, between that and what I did in the first case, except that it was a sort of a nicer way to organize things and may prove more valuable than listing things off when we have to kind of keep ourselves organized a bit better. Question 2 here, sort of saying basically, what if we have an additional option for the middle name, sort of a hyphenated middle name in this case? And so essentially, if we take what we had here, we recognize we can then branch this off one more time. Andrew could be followed by, what are they, Chase or Alex. So Andrew, Chase, Alex, Jeffrey, Chase, Alex, and so on. We had 6 options to here, 2 more after that, and so 12. So 3, then 2, then 2, and of course that gives us a listing of 12 possibilities here. I don't know why there's an extra row in there. And then the tree diagram that would allow us to get to 1, 2, 3, 4, 12 different possibilities here as well. Now, sort of final comment here, as you can see, listing is not going to be very effective when there's a lot of options, and the tree diagram is not actually that efficient because it quickly becomes messy. We got to the point here where we had to use a single letter to represent the final name because the names start to merge together. So neither of these is a great method, but they both allow us ways to organize things when we don't have another choice, when we don't know what the answer is going to be. Now, you may have also sort of seen, and if you didn't, you may have already sort of had the idea in your head that our options really ended up being this. 3 options in the first case, then 2 options in the second case, 2 options in the third case, and basically they grew on each other as in the tree diagram. So there was 3 times 2 times 2, or 12 options in the end. And this is what we call the fundamental counting principle. And so the product rule basically says that if something is going to happen and something else is going to happen, so sort of one thing then the other, a first action and then a second and then a second action, there will be m times n, so we can multiply to find out how many possible ways there are to do both. And this just kind of goes through that, saying 3 times 2 gives us the 6, times the next 2 gives us the 12. So if we just look at sort of continuing on with the examples here, During drop everything and read time, students go to the front of the class and they pick a magazine and a book. And how many different combinations would there be? Again, even without knowing sort of what we're doing in the course, your answer here would probably be, well, I have 20 choices here, 35 choices here. So when I pick magazine 1, I have 35 choices for my book. When I pick magazine 2, I have, another 35 choices. Magazine 3, and so on. And so there are 20 times 35. 700 different combinations of one magazine and one book. And again, one magazine and one book. The stress here being the and in this case. We are choosing one of these and one of these, so both have to happen. So of course that leads us to the other option, which will be the or option. What if you're asked to pick just one thing to read, either a book or a magazine? How many options do you have? Well, it shouldn't surprise anybody, I don't think. There were 20 magazines, 35 books. Of course, that gives us 55 different choices. And so 20 plus 35 is 55. Now this is sort of the important part here. This might seem very obvious to you, but you've intuitively used another fundamental counting principle called the rule of sum. Now admittedly, the rule of sum is not something I usually discuss because it is fairly intuitive, but again, just for the purpose of mentioning it, essentially in example 4, you pick one or the other option. So we've essentially grouped two options into one. So magazines and books were originally our two options, and now we have one option, something to read. And when we have that situation, basically we just add up the number of choices. There were 20 magazines, 35 books, and so that's 55 reading options. Okay, so an example with that, you're going to a wedding. Your options are for dinner, soup or salad as a starter, beef, chicken, or pasta for the main course, and for dessert, you have an option of 4 different pies and 2 different cakes, so 6 different options here. So essentially, when we're looking at how many different meals can we have, we're grouping the different or options together. Soup or salad, I have 2 choices here, but the grouping is really the starter group. So I have 2 choices for my starter. I have 3 choices for my main course. Again, with the understanding that these are ors, I cannot choose both the beef and the chicken. I cannot also choose the pasta with the chicken and so on. I am choosing one of these. So these are my 3 options for my second choice, really, which is my main course. And then I have 6 different desserts to choose from. So my options are 2 starters times 3 main courses is 6 times 6 desserts is 36 different options here. And then sort of just a quick little note saying, notice that even though the dessert option has an and in it, you really only had the one choice. So you sort of do have to interpret what you're reading a little bit that way as well. And then my final example here, to zoom out. Six-sided die, when a six-sided die is rolled 5 times, how many different outcomes are there? If we just sort of think about what I've got on the die for my first roll, I have 6 different options, of course. I could get the 1, 2, 3, up to the 6. My second roll is completely separate, so I still have another 6 options for that one, and then 6 options and 6 options. So I have 6 times 6 times 6 times 6, or 7,776 different options of combinations for 5 dice.